This is section 10.4, Solving Quadratic Equations. Before we begin, we want to talk about what our purpose is in this second half of the chapter. When we're solving quadratic equations, we're actually examining a parabola, which I've drawn 3 examples here in blue, and we're trying to determine how many times the blue parabola crosses the horizontal line, the x-axis. Well, this first one, it's pretty obvious that it crosses 2 times. The second one, it comes down and touches, and it crosses 1 time. But this third one doesn't cross at all, and so that crosses 0 times. Well, what we're going to be doing this second half of the chapter is determining what point these are exactly where it crosses. Where is that spot exactly? Is x equal -2, x equal -3, -3.5? We're going to try to exactly find those values for each of these. Now, sometimes remember, you may not get an answer, or sometimes you may only get one answer. So, with this as a preface, let's take a look at our examples today. A quadratic equation is going to have either, as we just learned, 2, 1, or 0 solutions. Our standard equation, as we had in the earlier part of the chapter, is ax squared plus bx plus c. Now, our goal is going to be to solve and isolate that x term. To do that, we start first by isolating the ax squared term. Then we want to get rid of the a by dividing by it just to have x squared remaining, and then finally we'll take the square root of both sides. When we take the square root of both sides, I want you to think with me, there's 2 possible answers, either positives or negatives, and we'll talk about what that is in a second. If we're taking the square root of a negative, there's no real solution. So let's look at our first examples here. We have m squared equals 16. Well, as we look at this problem, m squared equals 16, we're going to take the square root of m squared, and we're going to take the square root of 16. Now, a good rule of thumb, whenever you take the square root of both sides, you have to remember there's 2 answers, one's positive and one's negative, and so I put that in. The square root of something squared is what's inside, so that's m equals positive or negative 4. Now let's write all of our answers today in what's called set notation, so -4 or +4 as our answers, and using the brackets on the outsides. Here's our second one. We take the square root of x squared, and we take the square root of 100. Once again, remembering when you take the square root of both sides, you have a plus or a minus. So the square root of x squared is x, the square root of 100 is 10, and we have our plus or minus as our answer. So I write my answer, -10 or +10. Looking down at 2a, now we have subtracted 121 tacked onto the left-hand side. Well, our first goal is to isolate that x squared term. So let's add 121 to both sides. Now that we've done that, we have x squared equals 121. Now the problem is exactly like in 1a and 1b. We're going to take the square root of both sides, not forgetting that we have a plus or a minus out front, which leaves us with x equals plus or minus 11. Write it in set notation, -11 or +11. Let's look at the last one for this side of the paper. To eliminate the plus 25, we minus 25 from both sides. That leaves us with a squared equals -25. Now we take the square root of both sides. Remembering once again, you have a plus or a minus out front. The square root of a squared is a. Now we have to take the square root of a negative number. Well, if you remember from a couple lessons ago, we can't take the square root of a negative number, and so we don't have a solution here. And so the only thing we can say is there's no real solution.